I'm going to record myself grading this paper. One, so the student, Mr. Crowder, can get some feedback on his work. And the other reason is so the TA, Elijah, can get a little more insight on how I grade because I really need his help grading. So here we go. Let's take a look at this. So here's the pre-lab that you sent me. One of the first things I did was make sure it was shared with the correct people, and it is. So we can see Christopher Crowder is the person, and we are the two people grading it. Then I would scroll down here. Whoops, where are we at? There you go. Because before the pre-lab, they needed to do the questions. So I click on that link. The questions pop up, and I pulled up his want here to pull up his results, and he has 11 out of 12, and I just want to look and make sure that's correct, and it's not, see, because at this point I just hadn't gotten around to giving him a point for answering any two of these following questions. So there we go. I'll give him his point for that. Save that. So there we go, 12 out of 12 points. He has full credit for this portion, so I'll just leave that. No need to mention anything. Now let's go down here and look at the pre-lab here. So basically it's just saying, what's the definition of diffusion? The movement of substance from an area was more concentrated to is less concentrated. I'll take that. It would be better. I also didn't say something about until equilibrium is reached, but this will suffice, especially considering that I'm just now getting around to grading your pre-lab. If it was maybe if you turn this in, right away, and I had graded it right away and you had plenty of time to fix it, then maybe I would deduct a point for that, but in this case, no. Anyway, what is the definition of osmosis? The diffusion of water across a membrane. Yeah, I'll take that. Across a semi-permeable membrane, that might be a little bit better, but yeah, this is fine. Why does diffusion occur? Brownian motion. Good. What is Brownian motion? Random molecular motion. Good. Name the four factors that may affect the rate of diffusion. According to this introduction, they are concentration, size, temperature, and membranes. That is correct. Now let's go down and make sure that you did all the hypotheses. Which moves more rapidly, larger or smaller molecules? And you put smaller. Good. Not that it matters. You could put larger and you still would have been, that still would have been a valid hypothesis. So you wouldn't have lost a point. Anyway, molecules at higher temperature will move faster. Good. Let's keep scrolling down until I see the green. Here we go. The water will move into the cell. Okay. So predicting some osmosis there. Iodine will not move into the cell. Okay. Salt will move into the cell. I have to deduct a point here. I'm just going to do half a point because salt is already into the cell. So salt cannot move into the cell. It's already there. Oops. Here, let's just do it like this. Same with the starch, right? Starch is already in the cell. So minus 0.5. Now let's keep going. Water will move into the cell. Sucrose will move out of the cell. That's good. Tap will stay the same. Still will increase, decrease, decrease. Yep, that works. So that's it. And I can see that you've already done the rest of the lab. But my intention here is to, well, you know what? No, I'll just go ahead and grade the rest of the lab too while I'm at it. But anyway, so you missed half a point for this, right? So minus 0.5. I'll go back here, let you know what your pre-lab score is. So minus 0.5 out of 7, right? I think. Let me double check that. Yep, because we have 6 questions. And then if you include the video itself as one question, that's 0.5 out of 7. So let me show you the math. Pull up my calculator. 7 minus 0.5 is 6.5. Divide that again by 7 to figure out what your percentage for the pre-lab is, and it is about 92%. Multiply that by the total points possible for a pre-lab, which is 5. So multiply that by 5, and you got 4.64 points. 4.64 out of 5. Pre-lab. Okay. Now I'll go down and start grading the actual lab. So some of this is already graded, right? Because we looked at your hypotheses. But anyway, so those are your 2 hypotheses. Let's look at this here. Apparently that got too hot. I remember that. So that's why that's in A. Here we started at 2, 1 up to 3, got 1 millimeter of change. 2 to 5, just 3 millimeters of change. Good. 3 to 11, which is an 8 millimeter change. That's good. It's 3 to 14, 11. Good. And then once again, it got too hot and didn't work. So good. That math looks fine. Let's look at the graphs. Make two graphs. One should show the relationship between molecular size and rate of diffusion. The other one should show excuse me. So that should show the relationship between temperature and rate of diffusion. So yes, one size, one's temp. So let's take a look at here. Rate of diffusion, cold, warm, room temp. Very good. So let's see, we started, okay. So you did miss a point here. Because you don't have, like, what is this on the y-axis, right? You have to label your axes, right? So in this case, rate of diffusion, what are these numbers? That's not actually the rate of diffusion on the y-axis, right? So not only did you not include your units, but you didn't have a correct y label axis. So it should be, this is millimeters, right? So they all started at 2 millimeters, and then some of them went up to 3, some of them went up to 4, some of them went up to 5, right? So that's yes. Anyway, so 4, 5, 6, 7, 8. This is worth 5 points. So let's just say 1 point for each mistake, right? So -1 for the y-axis. Also, -2 because you didn't have a graph title. And even if you did, even if you meant for this to be the graph title instead of the y-axis title, even then it's incorrect because rate of diffusion versus what, right? What does this matter? We can't tell by looking at this graph that we are looking at the rate of diffusion. Well, yeah, sorry, I take that part back, because I do see, yeah, it's color coded. But anyway, so you have to -2 points total because it's 2 mistakes on that graph. Probably the same issue with this graph. Yep. Once again, no title. And again, the y-axis should say millimeters, or excuse me, the y-axis should say distance parentheses mm, right? Because what we're looking at here is the distance traveled, right? You could even write that distance traveled, or however you want to describe it, but you definitely want to have in parentheses mm, right? Anyway, so it's -2 for that graph. Let's see. Question 9 and 10, discuss your results. Question 10, 11, discuss your results. How was the molecular size rate of diffusion? What was you correct? I didn't. Okay, so I don't know why I'm reading those. So that's 1, 2, 3, 4 missing because it hasn't been answered yet. Let's take a look at here. Water in beaker after 30 minutes. Wait, water. At the beginning, it was in the beaker, not in the cell. Yes and yes. I don't know what that means. I assume this means at the end, it was in the beaker and in the cell. I'll just go with that. It would make sense for you to write in beaker, in cell. But that wasn't specific, so I get it. Anyway, in beaker, not in cell, yes and no. So that you're saying that the iodine stayed out of the cell. Not in the beaker, not in the beaker, but it is in the cell. Yes and yes. So you're saying that the salt diffused out into the beaker. Starch not in the beaker, but in the cell to start with, and then yes and yes. So you're saying that the starch diffused out into. So there we go. And let's look at the weight here. We went from 2.31 to 25.2. It's good that you did that, but I have to subtract half a point here, not the full point, but half a point, because you did not include your units. So what is that? 23.1 kilograms, 23.1 grams, 23.1 ounces, 23.1 pounds, right? You have to always include your units. Anyway, regarding the water diffusion, what was your hypothesis? Was it correct? My hypothesis was not correct because no water moved into the cell. Well, that's incorrect. You said right here that the water did move into the cell, right? So based on your own data right here, water did move into the cell. Additionally, we can see here that water gained weight. Yet you also say that stuff left the cell, right? So iodine didn't come into the cell. You're saying the only thing that came into the cell was water. And additionally, salt and starch left the cell, yet even though starch and salt left the cell, it still gained weight. Therefore, like we have two reasons to now understand that water did enter the cell, must have, based on your data. So I'll have to be -1 for that. Excuse me. Let's see. Regarding the idea iodine diffusion, what was your hypothesis? Was it correct or not? Yes, my hypothesis is correct because it did not move into the cell. All right, based on your data, that is true. Salt. That's my hypothesis is good because it moved into the cell. Okay, so according to this, the salt did. Wait, that's a tough one. Okay, first of all, well, this has to be wrong because first of all, your hypothesis, if you remember correctly, was that salt would not move into the cell, which I originally earlier told you that is incorrect because salt was already in the cell. So first of all, your hypothesis, you're misremembering your hypothesis here because your hypothesis, I don't know how to put this properly. It's confusing with the how you originally messed up the hypothesis. But anyway, salt did not move into the cell. So let's just focus on that part, right? Salt was already in the cell. Salt did not move into the cell. So that is why that one is incorrect. Right? Salt was already in the cell, so it did not move into the cell. As a matter of fact, according to your data, the salt moved out of the cell, right? And that's what the question should have addressed, right? Will salt move out of the cell? Had you done a correct hypothesis, then you would say yes, salt will move out of the cell, or no, salt will not move out of the cell. In which case, we could have properly addressed that with question 18. But this is where we are. No, my hypothesis was incorrect because starch did not go into the cell. Once again, yes, starch was already in the cell, right? So of course it didn't go into the cell. It could not go into the cell, but it was in the cell, right? And again, had we properly addressed the question originally, well, then we could address this, right? The fact that starch did leave the cell. But anyway, how do you know if water diffused into the cell or not? It went from higher concentration to lower concentration as the water did not move into the cell. So here we go. This is why this is incorrect. Because you're saying the water did not move into the cell. But it is, if you think about it, this is a higher concentration, right? Water, there isn't, you had pure water in the beaker to begin with. And in the cell, that little fake cell we made, we had a starch solution. So obviously, the concentration of water was higher in the beaker than in the cell, right? Because the cell was mostly starch and salt, and the beaker was almost entirely water. So we would have expected it to diffuse into there, right? We would have expected osmosis to occur for that reason. So, but anyway, going back to your answer, yes, water did move into the cell. So that's one of the reasons you're going to lose a point here. This means that it was not at a lower concentration. All right. Well, I do at least like your logic, so that was good, right? Had you been correct, had water not moved into the cell, then that would be correct. This means that it was not at a lower concentration. Wait, wanted to move. It's hard to address that. Let's just focus on this because water did move into the cell, so that is correct. Incorrect. But had this been a correct answer, it should have stated how do you know if water diffused in the cell or not? Well, it's all the stuff I said here earlier. The only way to tell if it moved into the cell is if it gained weight, right? If the cell gained weight, it had to have been from the water. Yes, technically a little bit of those iodine drops could have diffused in, but that's not going to account for that much weight gain, especially considering that salt and starch left, right? So it lost weight in salt and starch, but then it still gained weight. So we know that the correct answer to that would be we know it. Well, I don't want to give you the correct answer because I'll give you the chance to fix it, but keep that in mind. Anyway, how do you know if iodine diffuses in the cell or not? I know if iodine has diffused in the cell or not, if it has changed color. Good. When looking at the beakers, I noticed there was no color change, which means that the iodine did not diffuse in the cell. Well, no. That's where you're wrong because you're talking about the beaker. Doesn't mean it didn't diffuse in the cell. Just because there was no color change in the beaker, that has nothing to do with the cell. You need to address the cell, right? We're talking about, did iodine go into the cell? You're talking about what the beaker looks like. So that's why you lost a point on that. how do you know if salt diffused out of the cell or not? If the salt turns cloudy, good. This means that the salt diffused, good. It would help if right here you put if the solution in the beaker turns cloudy. But so far, I'll allow this for now. Let's keep reading. If the solution turns cloudy, then that means the salt diffused, which did not occur in this experiment. I'm going to have to take a point away from that too, because you said here that salt did go leave it left the cell, right? You said here at the beginning salt was not in the beaker, and then here it was in the beaker, right? So that tells me yes, this did occur. It was in the cell and did not come out of the cell, right? So everything about this answer is incorrect. The first portion I would have accepted, would have been better if it said it if the solution in the beaker as opposed to in the cell. But again, if it was just that one small mistake, you wouldn't have lost a point. But every portion of that answer is incorrect. How do you know if starch diffused out of the cell or not? This kind of goes back to the iodine question. But anyway, if there's a presence of violet, I assume that means violet, like the color purple, then that means the starch is diffused from the cell. All right. So once again, just to start off with, this would be more accurate if you told me where you're expecting this color change, right? So if the color changes outside, if the color changes in the beaker, then yes, that means the starch is diffused from the cell. But if the color changes inside the cell, then that goes back to that whole iodine question. But anyway, let's keep moving. For now, this is correct. A small mistake, you're not going to lose a point. The starch was still within the cell, meaning it was not diffused out of the cell. So once again, here we go. You have to lose a point for this because according to your own data, starch did move out of the cell. Anyway, let's move on to this next one. This one's a lot easier, right? Good. We have this one. Ironically, you did put grams on here, unlike last time, but this time you didn't need to because it was included in the table, but you're not going to lose points for that. But anyway, we went from 23, 24, 25, 28. So here, this is just a good learning moment. You're definitely not going to lose points for this, but this is a red flag to me. The fact that I went from 2.6 to 2.5 is a red flag. Why? It shouldn't gain weight and then lose weight. Now it could gain weight and then level off perhaps. So this indicates to me that there was some sort of measuring error. Something went wrong. And I don't know what happened here, but I'm not going to worry about that. So anyway, overall it did gain weight, right? So we know overall, I can tell that water did diffuse into the cell. So with that being said, let's look at these questions. What was your hypothesis was correct? My hypothesis was correct about water moving into the cell. So, well, I'm going to at least give you half a point off of this because it says, what was your hypothesis and was it correct or not, right? So you just said your hypothesis was correct. So now I have to go up and reread it and see what your hypothesis was. So let's take a look at this. Water will move into the cell. All right. So good. But anyway, you do have to miss half a point for this. And again, this is all for a reason. One, it helps the graders because we can't, we have a lot to grade and it really would take forever if we had to go back and check every single one of your hypotheses. And two, it's just a good habit to be in, especially when it comes to writing a lab report, right? You need to readdress your hypothesis. All right, regarding water diffusion. Whoops. That needs to be fixed. It should say regarding diffusion. So I apologize if that confused you. Regarding diffusion, what was your hypothesis? Was it correct? My hypothesis was incorrect because the sucrose did not move out of the cell. Now, again, you didn't repeat your hypothesis, so I have to go read it again. Sucrose will move out of the cell. All right, so that is correct. But once again, you have to miss half a point for that. How do you know if water diffused in the cell or not? Water did not diffuse into the cell as the cell did not get smaller. It got bigger. Okay. That's wrong, right? You just told me that the water did diffuse into the cell. That's why that's incorrect. But think about it. How do we know? How do we know water diffused into the cell? Look at your data. I'll tell you if you want. Ask me and I'll give you feedback. But I'm not going to tell you right now in the video because I want you to be able to answer this question and still get some credit for it. So for now, I'm not going to say anything, but ask me if you want. How do you know if sucrose diffused out of the cell? The concentration will move from higher. Yes, but that's not what that's asking. It's asking, as you're doing your experiment, how do you know, right? So that's what it would cause it, right? If it, when something has a higher concentration, it does go from a higher to lower concentration. Yes, that's what causes diffusion. But this question is saying, how do you know if it happened or not, right? This is an experiment. You said that sucrose, right? You told me up here that sucrose did not diffuse out of the cell. So how do you know that? Can you tell me how? What is it about your results? What is it about the experiment you did that you know that that sucrose did not diffuse out of the cell, right? That's how you need to answer that. Whoops, I accidentally erased it. Let me -1 here. So these are all a lot of mistakes, but they're all pretty easy to fix. Using the following formula to calculate the percentage. All right, so we started at 23.9, we ended at 25.5. So let's look at your numbers here. I don't know if that's your answer or not. 25%. I think that was the example. Let me take a look. I guess I don't normally do the math on these. As you look at it, and if it seems like it's in the right ballpark, then that's correct. But I'm not quite sure if this is your answer or not. So that's what I want to check. So final minus initial divided by initial, right? So let's pull up the calculator. The last weight was 25.5. That's how much it ended, right? And it started at, so minus the starting weight, which is 23.9, which means it gained 1.6 grams. I'm going to divide that by the original weight, which was 23.9 grams. Okay, good. And then so there's our we're almost to a percentage. Now you need to multiply that by 100 to turn it into a percentage, or move the decimal places 2 to the right. But I'll just go ahead and multiply it by 100 just to demonstrate it. And we have 6.69. I'll accept that. Good. So that is correct. Good job. And then this, good. You did your hypotheses, but we didn't do those experiments, so you're good. So this whole lab has 31 questions, right? So let's now add up how many you missed. 1, 2.5, 3, 4, 5, 6, 7, 8, 9, 10, 10.5, 11, 10.5, 11. So 15, 17, 19. All right, so minus 19. Minus 19. Let me double check that number. I think we said 31 was the total possible. 31. Yep. So where are we at here? Minus 19 out of 31 for the lab. Let's do that math, and I'll pull this up so you can see it. So we have 31 minus 19. So that means you got 12 out of 31 correct. So 12 divided by 31, that's the percentage, about 39%. Multiply that by the total points possible, which is 15, and you get 5.81. 5.81 out of 15. Reply to this comment if you make corrections. Here is a video of me giving feedback. Let's see. I'll give you 1 point of extra credit if you allow me to share this with future students. So yeah, this video is for you, for your feedback, but it would be helpful if you let me share it, because as you know, I have a YouTube playlist, and it would be good for future students. Well, they will have access to my YouTube playlist, and it would be nice if they could scroll through that playlist and see that there's feedback for this lab, and then, hear what I had to say and hopefully learn from your mistakes. But I'll leave that up to you. Let me know what you want to do. And that is it.